Okay, let's start today with a phrase that sounds, well, honestly, it sounds less like a technological breakthrough and more like a very specific type of accident.
Right.
Something you'd have in a high school chemistry lab. Gaussian splatting.
It does have a certain chaotic ring to it, doesn't it?
It really does.
Like you dropped a beaker of neon paint and just hope for the best.
Exactly. It sounds like art gone wrong, or maybe what happens when a tomato hits a windshield on the highway at like 70 miles an hour.
Yeah.
But as we went through the research for today's deep dive, it turns out this is actually one of the most sophisticated shifts in 3D visualization we've seen in the last decade.
It really is. And despite that messy name, Gaussian splatting is, incredibly precise.
Okay.
At its core, it's a technique for taking 2D images.
So video, photos, whatever you have on your phone.
Exactly,
Yeah.
and reconstructing a photorealistic 3D scene from that. But unlike the old methods like photogrammetry, which could take hours or even days to process, this is fast. It's efficient, and it handles things like reflections and transparency in a way that used to be basically impossible.
So just to set the baseline here,
Oh.
we're taking the flat world videos on your phone, drone footage, and turning it into a 3D environment that actually looks real. Not just some blocky video game version of reality, but the actual fuzzy, messy reality.
That is the baseline, yes. But the mission for this deep dive isn't just to explain how we make pretty 3D pictures.
Okay.
We're tracking a specific evolution. This technology, it started inside the high-walled gardens of big tech and heavy industry, but the sources we have today show it breaking out.
I see.
We're moving from industrial inspection tools to something accessible for creators, gamers, and developers.
The democratization of reality capture. I love that narrative.
Right. We're going to figure out how we get from a static 3D scan in the real world, which is cool, but kind of just sits there like a statue,
Right, you can look at it, but that's it.
to a functional, walkable digital environment.
And to guide us, we have a really interesting stack of reports. We've got analysis on the industrial application of this tech-think-heavy utilities infrastructure.
Sure.
But we also have a deep look at a specific, almost cyberpunk new utility suite called Splatwalk, developed by Eric Eisenman.
Splatwalk. It really leans into the terminology.
I know, I love the names in this industry. But before we get to the neon interface of Splatwalk, let's ground this.
All right.
Why is everyone from construction managers to utility companies obsessed with these splats? What's the business case here?
It really comes down to the concept of the digital twin.
A digital twin. I hear this buzzword a lot at tech conferences. It usually just means a computer copy of a thing, right?
Historically, yes. But in the context of Gaussian splatting, it means a copy that is accurate enough to make, well, expensive business decisions on. The reports we looked at highlight how this is revolutionizing the utilities infrastructure sector specifically.
Utilities. So we're talking about power lines, water pipes, substations.
Yeah.
The stuff we ignore until it breaks.
The very stuff that keeps civilization running. It sounds mundane, but the implications are huge.
I bet.
Utilities are using Gaussian splatting for maintenance and remote diagnostics. Imagine you have a critical piece of infrastructure in a remote location,
Okay.
a transformer on a mountain or a pipeline in a desert.
Traditionally, if something goes wrong or even just for a checkup, you send a guy in a truck.
You send a team. It takes time, fuel, and it's dangerous. But with this tech, they can create a real-time 3D model from what the industry calls sparse data.
Sparse data. Does that mean they don't need a Hollywood film crew to scan the telephone pole?
Precisely. That's the Gaussian advantage. A few images or a quick drone pass can generate a model detailed enough to detect leaks, corrosion, or equipment damage.
Wow.
They can see the rust on the bolt, not just a blurry texture. It helps them respond to outages faster. But there's a fascinating sociological layer here that the research pointed out, which I thought you'd appreciate.
Oh, we caught that note. It's about the retiring workforce, right?
It is. The industry is facing a massive brain drain. You have senior engineers who have known these specific systems for 40 years. They know the quirks of every substation. They know that if this specific pump vibrates at a certain frequency, it's about to blow.
Right. They have the knack, but they are retiring.
They are retiring, moving with Florida, and taking that institutional knowledge with them.
That is a huge problem. If Bob is the only guy who knows the secret handshake for the generator, and Bob leaves,
then you're in trouble. So by using this technology to create high-fidelity 3D models, they are effectively archiving the state of the infrastructure.
See.
It creates a spatial database that new engineers can explore virtually. It helps bridge the knowledge gap. It's technology specifically addressing a human resource crisis.
That's wild. So it's not just about looking cool, it's about archiving reality because the people who understand it are leaving.
Yeah.
Now, the notes also mention AEC.
Architecture, engineering, and construction.
Right. The source material mentions Sigma technology platforms operating in this space. They're using splats for browser-based 4D site reconstruction. Now, I assume 4D means the fourth dimension.
Look at just time.
Okay, so how does that work on a construction site? We aren't time traveling yet.
Well, think about a skyscraper being built. It changes every single day.
Sure.
Because Gaussian splats are so easy to make, again, just phone or drone footage contractors can scan a site every morning. This supplements BIM, or building information modeling.
So it's like a daily backup of the physical world.
Exactly. You can literally scroll back a timeline. You can see what the plumbing looked like inside the wall before the drywall went up 3 weeks ago.
Which saves a massive headache 3 months later when you need to drill a hole and don't want to hit a water main.
And it's indisputable. It's not a drawing that might be wrong. It's a photorealistic capture of the site at that exact moment.
I can see why that's valuable. It's accountability. And then, of course, you have the enterprise AR/VR sector manufacturing retail.
Right. They are streaming these photorealistic assets for training. If you're teaching someone to repair a jet engine, you want the engine to look like a real engine.
With all the grime and everything.
With all its grime and specific lighting, yeah, not a sanitized cartoon. The key metric here is faster rendering. Gaussian splats are incredibly efficient to render compared to traditional polygon meshes.
We can't talk about this landscape without mentioning the giants, though. The usual suspects are all in the report. Niantic, Google, Snap, Meta.
They are the heavy hitters. They're leveraging this for spatial computing, mapping the world, and building the metaverse, whatever that ends up looking like. Their goal is to transform real-world capture into something you can interact with on a global scale.
Okay, so that's the macro view. You've got Google mapping the planet,
Yeah.
and utility companies checking for rusty pipes. It's very industrial,
Yeah.
very top-down.
It is.
But here is where the research gets really interesting for us regular mortals.
The transition from the industrial to the personal.
Right. Because scanning something is one thing, but doing something with it, interacting with it is another. The notes call this the challenge of the splat.
This is the hurdle that has kept this tech largely in the realm of visualization up until now.
Pivot with me here. Let's say I take my phone, I scan my living room with a splatting app, I put it on my computer, it looks perfect, photorealistic. I can see the dust on my coffee table.
Okay.
But if I tried to drop that scan into a video game engine like Unity or Unreal, and I tried to walk my character across the floor, what happens?
You would fall right through the floor.
Into the void.
Into the void.
Because ghosts don't have feet.
Well, technically because the floor doesn't exist, not as a solid object.
Explain that. It looks like a floor. My eyes tell me it's a floor.
Computationally speaking, a Gaussian splat is a point cloud. It's a collection of millions of little blob splats that have color, opacity, and scaling information.
Okay.
They just float in space. To your eye, from a specific angle, they blend together perfectly to look like a rug, but to a physics engine in a game,
There's nothing there.
there is no surface, there is no collider, it's just gas, it's colored fog.
So it's a hologram. You can see it, but you can't touch it.
Exactly. And that is where this tool, Splatwalk, comes in. The source material describes it beautifully as a bridge.
A bridge from the messy, beautiful reality of a 3D capture into the structured, walkable domain of a simulation. I love that description.
It's a vital distinction. It takes something that is purely visual, an optical illusion, really, and gives it physical substance.
So let's pop the hood on Splatwalk. This tool was developed by Eric Eisenman. How does it actually turn my ghost living room into a solid floor?
The tech stack here is genuinely impressive, especially for something that runs in a browser.
Really?
It's using high-performance Rust via WebAssembly or WASM.
Okay, hold on. Rust via WebAssembly. For those of us who aren't software engineers, the source used a great analogy for this. That's like putting a rocket engine in a golf cart.
It's a fitting analogy. Think of your web browser Chrome, Safari, as the golf cart. It's convenient, it goes everywhere, but it's not designed for speed.
Right.
It's designed to show you text, images, maybe stream a video. It usually runs JavaScript, which is fine, but it's not heavy duty.
It's not meant for crunching millions of 3D points in real time.
Correct. Rust is a programming language known for extreme speed and memory safety. It's what you'd write a serious operating system component or a high-end game engine in.
I see.
WebAssembly allows that high-power code to run inside your browser. So Splatwalk brings native app performance, that Rocket engine, directly into the golf cart of your browser.
So you don't need to install a massive 10 GB program. It just runs in a tab.
Correct. But the real magic isn't just the language, it's the algorithms it runs with that speed.
Okay.
There are 3 key features we need to unpack to understand how it solves the ghost floor problem. The first is Ransack ground plane detection.
Ransack. Sounds like a sci-fi villain. I am Ransack, destroyer of worlds.
It actually stands for Random Sample Consensus. It's a statistical method. In this context, imagine you have millions of these floating splats.
Yeah.
Some are the floor, some are the table, some are just noise or artifacts from the scan. The software needs to figure out which ones represent the ground.
So it's looking for a pattern.
It takes random samples of points and checks if they fit a mathematical model of a flat plane. It does this thousands of times instantly.
Wow.
It essentially votes on which plane has the most points fitting it.
So it looks at the cloud and says, okay, mathematically, this flat area here, that's the floor.
Yeah.
That is where the character stands.
Exactly. It creates a reference point for gravity. But once you have the floor, you still have a problem. The objects, the couch, the table are still just floating points.
You can't bump into them yet?
Not yet. That leads us to the second feature, Poisson reconstruction.
The source described this one as a digital skin graft, which is visceral but evocative.
It is, but it's accurate. Poisson reconstruction takes those floating points and calculates a surface that connects them. It wraps them in a smooth mesh, specifically a .glb file.
So it connects the dots.
Yes. It creates a watertight surface. It takes the ghost cloud and wraps it in digital skin so it becomes a solid object that a game engine can understand as a barrier.
Now you have a shape.
Now you have a shape.
Okay, so now we have a floor, we have solid objects. But that's not enough for a game, is it? Just because something is solid doesn't mean the computer knows how to walk on it?
No. Just because an object is solid doesn't mean a character knows how to navigate it. If you've ever played a game where an enemy runs into a wall and just keeps running into it, or spins in circles,
Or gets stuck behind a small rock.
that's a failure of the nav mesh. And that's the third piece of magic in Splatwalk.
Nav mesh. Navigation mesh.
It's fundamental to gaming. A nav mesh is an invisible map overlay, usually simplified geometry, that tells the AI characters, this blue area is walkable, this red area is a wall, this drop is too steep to walk down.
Right.
The source mentions Splatwalk uses recast-compatible binaries.
And recast is the industry standard for this.
It is. It's what big engines use. So this tool isn't just making a shape. It's defining the rules of movement within that shape.
So this is the difference between a character walking through a table like a ghost
Yeah.
and a character knowing they have to walk around the table to get to you.
Exactly. The source puts it well. This isn't just a pretty picture anymore. It's a world where NPCs, non-player characters, can actually think and move.
That is a massive leap. You're going from a video scan to a functional game level, all happening in a web browser tab.
Yeah.
But we have to talk about the style of this tool. Because apparently Splatwalk doesn't look like your typical boring utility software.
No,
It doesn't look like an Excel spreadsheet or a standard CAD program.
not at all. The interface seems to be a statement in itself.
The source material compares the vibe to Cyberpunk 2077. We're talking neon pink borders, glowing blue text.
And glassmorphism.
Yes, that frosted glass look where the background blurs behind the panels, and the system logs scroll by in Fira code.
Which is a monospaced font used by programmers. It creates this feeling like you're in the Matrix, watching the raw code of the world stream by.
It's interesting, isn't it? Usually developer tools are very utilitarian. Gray buttons, white background, file, edit, view.
For sure.
But this is Sigma production. The philosophy seems to be that visual excellence is a requirement, not an afterthought.
It reflects the user base they are targeting. This isn't just for civil engineers checking pipes anymore. This is for net runners.
Right.
It's for creative coders. It creates an atmosphere.
My favorite detail from the notes is the generate mesh button. It's not just a gray box.
No.
It's described as glowing like a radioactive emerald.
It adds a sense of power to the action. You aren't just clicking submit. You are initiating a transformation. You're compiling reality.
And it's built for usability, too. Doesn't create the flashy look. It mentions mobile flyouts for aligning splats on the go and adjusting voxel targets with a slide. It feels like something a hacker in a movie would use to break into a mainframe. but it's actually for making art.
It balances that hacker aesthetic with genuine user experience design. It makes a highly complex mathematical process, Poisson reconstruction, ransack calculations feel accessible, even tactile.
Yeah, you just slide a bar and the mesh changes.
Exactly.
Which leads us perfectly into the future of this stuff. Because Splatwalk isn't just a cool toy, it's changing who gets to play in the sandbox.
This is the democratization aspect we touched on earlier. The tool converts .spz and .ply files.
Which are the standard scanning formats.
Right, the stuff you'd get from a high-end scanner or a generic app into efficient, game-ready assets.
And the promise is the one-click workflow.
Right. Taking complex geometry and making it usable with minimal effort. This lowers the barrier to entry significantly.
Think about the difference. 5 years ago, if you wanted to put your neighborhood into a video game, you'd have to model every house by hand.
Oh, yeah.
You'd need to be a 3D artist, you'd need to texture it, light it.
Or you'd need a LiDAR scanner that costs as much as a luxury car and a team to process the data. Now, you don't need a degree in computational geometry. You can turn a drone video of your backyard into a game level where you can chase zombies.
And it's open source, right? That's a key part of this.
Yes, the source links to a GitHub repository by Eric Eisenman. It invites developers to build the WASMN and contribute. This is crucial because it means the community can improve it.
It's not a locked box owned by a massive corporation.
Exactly.
That feels like a big shift. We started this deep dive talking about Google and giant utility conglomerates using this to save millions on maintenance. But now we're seeing that the power to create these digital twins is moving to the individual.
That is the bigger picture. We are moving toward a democratized metaverse, if you want to use that term.
But not the corporate version.
No, not the one where you buy virtual land from a company.
Now, this is different. It's not about consuming worlds built by Meta or Google. It's about scanning your reality and importing it into the digital space.
Exactly. It shifts the user from a consumer to a creator. You own the scan, you process it, you build the game.
So a developer can take a drone video, run it through this radioactive emerald button, and 5 minutes later, they have a level.
And a browser, that is the key. The accessibility is the revolution here. You don't need a render farm, you need a laptop.
It really is. We've gone from detecting corrosion on utility poles to walking around a cyberpunk interface creating worlds. It's been quite a journey through these sources.
It shows how quickly technology matures. What starts as an industrial necessity for inspecting pipes becomes a creative tool for artists and gamers. The cycle is getting faster.
So what does this all mean for you listening? It means the line between scanning the world and playing in the world is disappearing. Thanks to things like ransack detection and nav meshes, reality is becoming a drag-and-drop asset.
And empowers you to preserve and interact with your environment in ways that were impossible just a few years ago. It turns memory into space.
Before we sign off, I have a question for you to chew on. Since we now have the tech to turn any video into a walkable game level, if you could scan any location in the real world, maybe a place you can't visit anymore, childhood home that's been sold, or somewhere totally off limits like the Vatican Archives, and instantly turn it into a video game level where you could walk around, where's the first place you would go?
That is a fascinating thought. The ability to revisit memories spatially, to walk through a moment in time, that is powerful stuff.
Think about it.
Yeah.
And hey, keep exploring this messy, beautiful reality. We'll catch you in the next deep dive.
Goodbye, everyone.
See ya.